Hello friends, welcome to engineering tutorial. So we'll continue our discussion on thermodynamics. Previously we discussed about the basic concepts related to specific heat, heat capacity, molar specific heat and water equivalent. In this video we are going to discuss about calorimetry. Okay, so basically before we discuss calorimetry, let's just review some quick concepts related to heat, because it is basically calorimetry is the measurement of heat, the branch of physics which deals with the measurement of heat. So some quick review. We know that heat, which is basically energy in transit, energy in flow, and that energy flow or the direction of energy flow, it is determined by temperature. Heat flows from a body which is at a higher temperature to a body which is at a lower temperature. Okay, that we have already discussed in heat and temperature in that discussion. There is another important concept which is thermal equilibrium, which you need to be clear about before we discuss calorimetry. So let's say we have two objects. Okay, we have two objects. This is one object, let's say object A, which is at temperature TA, and we have object B, which is at a temperature T subscript B. Okay, here let's say we assume that temperature of object A is greater than temperature of object B. So obviously, as TA is greater than TB, so heat will flow from A to B. Okay, heat will flow from A to B. As heat energy, it is moving from A to B. A is losing energy, B is gaining energy. So temperature of this object A, it will go down, and temperature of B will go up. And finally, when both the temperatures they become equal, which is called as the equilibrium temperature or thermal equilibrium temperature, then the flow of heat, it stops. Okay, thermal equilibrium temperature, let's call it T subscript E, equilibrium temperature. So the thermal equilibrium temperature is in between TA and TB. Okay, TA and TB, it is somewhere in between. So it is in such a way that the equilibrium temperature is lesser than TA, but it is greater than TB. Okay, this. Let us say if we assign some values to it, let's say temperature of A is 100 degrees Celsius and temperature of B is, let's say, 20 degrees Celsius. Okay, this. So heat will flow from TA to TB, it will flow, and finally let's say the heat flow, it goes on till both TA, it decreases to 60 degrees Celsius. Okay, and the temperature of TB, it increases to 60 degrees Celsius. Okay, so the equilibrium temperature is 60 degree Celsius. So this equilibrium temperature, it is lesser than temperature of A, the initial temperature of A, which is 100 degrees Celsius, but it is greater than the initial temperature of B, which is 20 degrees Celsius. This is the concept of thermal equilibrium. Now we need to be we have discussed it in the previous video, but again, as this concept will come here, so the concept of specific heat. So specific heat, as we all know, it is the amount of heat required to raise the temperature of unit mass, that is 1 gram or 1 kg of a substance through 1 degree Celsius or 1 degree Kelvin, depending upon which unit you are using, CGS or SI. So it is given by this. Let's say we supply heat energy delta Q to a mass of a substance M, okay, M kg or M gram, and the temperature of that substance, it increases by delta T. So specific heat is delta Q by M delta T, which is basically, it is specific heat is this by delta T, which becomes delta Q by M delta T, or we can write it as delta Q is equal to MC delta T, which is the heat energy supplied, MC delta T, which is given by this MC TF minus TI, where TF is the final temperature, TI is the initial temperature. Okay, M is mass, C is specific heat of that object, and delta Q is the heat energy. And always remember, there are two unit systems, CGS and SI. In CGS, heat energy is in calories, then temperature in degrees Celsius, and mass is in grams. Here it is joule, Kelvin, kg. Okay, this. Now, coming back to the topic, which is calorimetry. So calorimetry is that branch of physics which deals with the measurement of heat, basically specific heat, heat capacity, molar specific heat, water equivalent, all that. We have discussed the concepts previously, but how to measure it? So that is done through calorimetry. So the basic principle of calorimetry is based on the concept of thermal equilibrium, which we just discussed here. So according to this principle, when two objects or two bodies at different temperatures, one higher, one lower, it is placed in contact with one another, heat flows from the body which is at a higher temperature to the body at lower temperature, till both the bodies, they acquire the same temperature, that is the thermal equilibrium temperature. That is the basic principle of calorimetry. Here, according to this principle and the law of conservation of energy, heat gained by the cold body, as heat is flowing from hot body to cold body that is at a higher temperature to lower temperature. So the heat which is gained by the cold object is the same as the heat which is lost by the hot object. That is the basic principle of calorimetry, which is also based on the law of conservation of energy. Okay, if we neglect the heat loss to the surroundings, so the calorimeter is designed taking into consideration that. So the basic construction of the calorimeter is something like this. It consists of a cylindrical copper vessel, okay, and it is kept inside a wooden jacket or a wooden encapsulation chamber, okay, for insulation purposes. Then to provide extra insulation, glass wool is used, which is coated around this copper vessel to prevent any heat loss to the surroundings. Then the extra insulation is provided to further prevent loss of heat due to radiation by polishing the outer surface of the calorimeter and the inner surface of the jacket. Okay, this outer copper vessel and the inner region or the inner surface of the jacket, that is also polished to prevent any heat loss due to radiation. Then to measure the temperature, we have a thermometer which is inserted into the copper vessel, which mainly it contains water but can contain also other substances, but in this case we are considering water as the cold object, and we have a stirrer. So here how this whole thing works. Okay, so the inside of the calorimeter, it is like this. Okay, we have water, which is the cold body or the cold object or substance. Okay, water is the cold object at a lower temperature. So it will, let's say it is at a temperature TW. Mass of water present inside the calorimeter is MW and specific heat of the water is CW. Okay, this is for water. Then the object, the sample, the substance, let's call it X, which is at a higher temperature, the hot object, the specific heat of which we want to measure. Okay, that is what basically calorimeter is. We want to measure the specific heat of this object. Let's say it has a mass X. Okay, specific heat is Cx, which we want to measure, and it is at a temperature Tx. Obviously Tx is greater than Tw because this is the hot body and this is the cold body. So when this object is placed inside the calorimeter, this object, the sample X, it will lose heat because it is at a higher temperature. Okay, it is at a higher temperature, so it will lose heat. Heat will flow from this sample, this object X, to water, okay, which is at a lower temperature. So obviously the temperature of this sample, it will go down from Tx, and the temperature of water, it will go up from Tw. So finally this will continue till both the objects, they acquire the same temperature, which is called as the final thermal equilibrium temperature, T. So temperature of X, it will decrease up to Te, and the temperature of water, it will increase up to Te. Okay, temperature of sample X will decrease to Te, temperature of water will increase to Te as heat is flowing from sample X to water. This is losing energy, this is gaining energy. So according to the principle of calorimetry, heat gained by the cold object, that is in this case water, is same as heat lost by the hot body, that is object X. So that to write the heat equations, the heat lost by sample X to water, that is given by this, which we discussed in specific heat here, mc delta T. Heat lost or heat gained, whatever it is expressed as mc delta T, where m is the mass of the object, c is the specific heat of the object, and delta T is the difference between final and initial temperatures. So for the sample X or object X, mass is mx, specific heat is Cx, and final temperature is the thermal equilibrium temperature T, initial temperature is the higher temperature Tx. Now as you all know, Tx is greater than T because temperature of the sample has decreased from Tx to T. So the final equilibrium temperature is lesser than the initial temperature of sample X. So it is final minus initial, mx Cx T minus Tx, it will be negative, so that's why minus sign comes to denote heat loss. And the heat gained by water is same, mc delta T, here mw Cw, which is the mass and specific heat of water, and Tf minus Ti, the final temperature is T of both water and the hot object, and the initial temperature of water is Tw. And as T is greater than Tw, the equilibrium temperature is greater than Tw, so it will be positive. Why it is greater? Because temperature of water has increased from its initial temperature Tw to final temperature T. Okay, this, always remember this. Okay, the equilibrium temperature is lesser than the initial temperature of the sample X, the hot body, and greater than the initial temperature of water, the cold object. Okay, So this is the heat loss equation for sample X. This is the heat gain equation for water, okay, according to this formula, okay, mc delta T, which is mc Tf minus Ti. So according to the principle of calorimetry, heat lost by the sample is equal to heat gained by water. So if we equate these two, it will be minus mx cx T minus Tx is equal to mw Cw Te minus Tw. So if we turn this into positive by taking Tx minus Ti here, this will be plus, it will become plus, minus minus become plus. So this becomes mx cx Tx minus T is equal to mw Cw T minus Tw. Our objective here is to calculate the specific heat of the sample, because everything else is known, we have determined, okay. Mx is known, Txt we have already calculated by inserting the thermometer and all that, mass of water is known, specific heat of water is known, equilibrium we have already calculated by taking the initial readings. So we want to determine the specific heat of object X. So that is equal to this mw Cw into T minus Tw by mx into Tx minus T. Okay, this is the calculation of specific heat of the unknown substance or unknown sample X, object X. This is the whole concept of calorimetry, okay, the principle of calorimetry. Okay, yeah. So here, using the principle of calorimetry, loss of conservation of energy, heat loss equation through specific heat, heat loss and heat gain equation, we have determined the specific heat of this unknown sample where everything else was known, mass, temperature, specific heat of the cold object or water in this case. So we had to determine the specific heat of this sample X. Okay, this. So here we have calculated that. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.